Now, the next project that I wanted to talk to you about is called Habitus, which is kind of slightly more advanced, I would like to think of it. It's another open source project that we are announcing today as open source. It was closed source till now, and yay. And we built it for ourselves, and I'll tell you why we had to build this thing. And we use it quite heavily ourselves. If you're into building Docker images, you'll realize that's a useful thing. And now we're working with CoreOS and a bunch of other companies just because they love it, they want to contribute to it as well, which is quite cool. So what is Habitus? It's a Docker build tool. So you can see it on habitus.io. I don't know why the logo looks like an elephant's bum, but here we go. So what does it do? Normally, you create a Dockerfile, which is quite simplistic. You create a base, and you create a bunch of layers on top of it, and you have a Docker image. But what if your build is more complicated than that? What if you have some scenario like this? Let's say I have a Java application, or a Go, just because I like Go. I have a Go application. I have to build it, i.e. compile it. Then I want to have two images created on that, one for the API, one for the web. And then I want to upload it to my S3 bucket so everybody can download them, right? It's more of a complicated build. But as well as that, there's another thing going on here. When I compile a compiled language like Java or like Go, I have to build that image with compile libraries, with compile time libraries. Like, for example, you might want to have, if you're doing like ImageMagick, or if you're doing Go, you might want to have GCC, like your C library, your C compiler. You might want to have some libraries, which you won't need if you're running it in runtime. What it would do is it loads the image, makes it slower to download, and just uses more space. But I think more importantly, it increases the attack surface, packages that you have to keep up to date, and just it becomes a group picture with a lot of people moving around. So you might want to do something like, I want to create this compile time image, compile it, then take out the compiled one, put it into another image, build that one, and then take the artifacts of that and upload it to S3, something like that. Or even something more. Imagine that you want to pull out the code from Git repository, and it's your private Git repository. You need a private SSH key. If I go and say git pull as a layer in my Dockerfile, I need to have an add command in my Dockerfile that says add SSH private key there. And by just doing that, I've added and included my private SSH key into a Docker image that somebody might just go and say by mistake, Docker push, and that's it. It's public. Everybody's got my private key. So what do? You have to take that layer out, or you have to pull the private key from somewhere else. And if you take the layer out with a delete, obviously it's kind of in the history. It's like Git history. You cannot rewrite history in the majority of cases. So therefore, it doesn't matter if you do a delete. You want to squash that image, essentially just yank out that image altogether, that layer. So these are the things that Habitus does. Here's an example of a build.yml. It's another YAML file that you can create to build complicated steps of build. So the first step, I'm going to call it compile. It's an arbitrary name. The name is compile. The Dockerfile that it's going to use is dockerfile.compile, because you can have just arbitrary named Dockerfiles. That runs. Then it does something that I don't know. It's a Dockerfile. Let's say it creates a project, an executable called Iron Mountain. It's actually a real thing. And puts it there. What I'm going to do with Habitus is going to go in there and pull that file out. So it not only does it build the image, it fires up a container based on that, goes to that container, pulls the executable out, puts it into your build context. So the next step, let's say API, can have an add Iron Mountain. And Iron Mountain will be available there. So I basically moved an artifact from one image to another one. I can have commands to delete as well. So this was what I was talking about when I was saying about private keys. So when I do something like remove RF any SSH keys that's there, it doesn't just run that command. It runs that command, but also squashes it. It pulls that image layer out. So your image does not have any trace of your private key in there. And then that was the API. And then you have web, which is the same one. And I have the upload step, which at the end it's just a Docker file that we've created. It's just S3 CMD, which is a command line tool to upload things into S3. Takes in my access key for Amazon, secret key, and uploads that into S3, my buckets, right there. And you can have dependencies there. So I'm saying my API depends on compile step, my web depends on compile, and my upload depends on both web and API. So it builds a dependency tree and then runs each step, multiple of those in parallel if they don't depend on each other. So any independent step will run in parallel for faster build. It does all of that with just saying, Habitus, point it to something, and get it running. As you can see, it supports syntax like environment variable replacement, so you don't have anything in your source control that has things like AWS keys or SSH keys and things like that. Any questions so far? Okay, cool. Now, as I said, you can go to habitus.io, have a look at this. It's an example of how it works. It is open source now, so you can go to GitHub, see the source code, all that sort of stuff. And you can read about artifacts, how they move around between different images. The cleanup step, which squashes and yanks out layers from the images. Image sequencing, which is quite interesting. So you might want to do something like build one step, and the second step from is actually previous step. So not only do you move the artifact, you create the base image for the next step in the prior step. And you can run multiple of these ones at the same time on the same build machine. What it means for you is you can actually have a Docker build machine, a server in your office. Now what happens is all of you have done Docker most of you have done Docker in development, and when you want to build a Docker, you just go Docker build, and if you're unlucky and you have a file that you don't want to have on your local, you might have it add dot, and that file ends up in the image. If you have a build server, you can have a repeatable, reproducible, if I can say it, image build system. And for that to happen, you need to be able to do parallel builds. So if I commit something and it triggers a build, and my colleague commits something and triggers a build, they can run at the same time. So Habitus takes care of that by assigning a session ID to each one of them, tagging each image that it builds into sessions and trunks. So it can actually you can run multiple parallel Habitus instances parallel to each other. Step dependencies we talked a little bit about. Environment variables, fairly standard stuff. You can also run a command, which is like upload the image or whatever that might be. And that's basically it, and a bunch of command line things that you can do about how to find the Docker daemon and stuff like that. Okay? I'm just going to run it once so you see how it looks. Okay, so I actually forgotten the syntax. Okay, the work directory is -d. I'm going to point it to a Go language project that I have. Okay. I have a bad YAML file. So here's it's probably that dash. I have not run this part. There we go. It's probably not that. I'm just going to, sorry? I can't hear you, sorry. Shouldn't be. Dash. I'm just going to take this one out for now. Yeah. Okay. So I'm guessing there's a tab slash space issue somewhere here. Oh, that's the well, that's the British spelling. Right. All right. I'm not going to debug it now. I guess it's my local build that's not working. But as you can see, like this one has tagging around it, so you can actually have tagging around that as well. And there's one caveat that we have not been able to solve, and there's something that if you guys are interested in a challenge would be great. And that is the squash part where it actually pulls out an image. It requires images, files within the Docker image to be moved out to temporary folder so it can be written back without the ones that were kind of pulled out. And it requires the Linux permissions on the file for GID and UID to be preserved, and that requires sudo rights. So if you want to run Habitus, you need to run it in sudo if you have a cleanup command step. If you don't, you can run it without that. And that's something obviously you want to avoid and not have if you can. But then again, it's a tool for your laptops or your internal build server in the company, so it should be okay. Everybody within the company is trusted. But ideally, you want to avoid that step as well. And that's another thing that's there. Okay, with that, I think I'm done. If you have any questions or anything you want to comment or ask, would love to answer it. Otherwise, thank you very much.
When Cloud 66 is running analyze, that's
yes.
the starter? When the GUI is running, it says analyze?
Yes. Yeah. Oh, actually, kind of yes and no. We have two products, Cloud 66 for Rails and Cloud 66 for Docker. And the Cloud 66 for Rails does actually run that starter step. It's not starter itself, but pretty much what we built in starter is coming from those heuristics that we learned from how people put gems, where they put it, what they do with it. The analyze part on the other side is another thing. And that is, there are two ways that you can run Docker in production with Cloud 66. One is, I have my own build system for Docker. It's working. I don't want you in there. I'm just going to give you a Docker image. I'm going to say, I have it in Quay.io, or I've got it in JFrog or somewhere, and it's my Docker repository, and it's built, it's QA tested, CI is run on it. You just pull that out. Here's my credentials. Go and pull it out and deploy it to my servers. In that case, Analyze really doesn't do anything. It immediately comes back and says, OK, I can check that your repository credentials are OK, and you have the image that you say you do have. But if you say, I have this Git repository, and here's my private SSH key, then what we do is we actually pull that code out. We run it through Habitus to build the image for you in a hosted way. So if you don't want to have your own build server in-house, you can actually use Cloud 66 for that. And not only that, it builds it, and then we give you a private Docker repository to push it out to that repository, which is then available near your servers that you want to deploy it. So it just immediately pulls it out to the servers, and they get started. It also does things like versioning of it. So you can have a look at this, which is quite interesting. Because if you look at like our other stacks on Cloud 66 itself, like internal services, probably one that we're running with Docker as well, you can see that we basically have like a build timeline. How many times we built that image, how many times we published it, as in rolled it out. So you can say, I want to roll back to that hash of the image. And what we found is quite as interesting as this. In the old school of way doing things, you have like this your Git repository, and you have a hash for each Git ref that everybody like commits and changes something, and it goes to production and say there's a performance degradation, like you have the site goes slow. And then the sysadmins or the developer managers can go and say, site slow, this deployment, what comment's gone into it, what's the issue? Somebody just said sleep 10 because they wanted to test something. Let's just say for the sake of argument. When you have Docker involved, you actually have two repositories. One is your code, the other one is your Docker repository. So there's like a break in the flow. As well as that, you might have multiple versions of your app running in flight. Like old versions are draining traffic, the new version is coming up, and the request goes slow, some of them go slow, some of them don't. You need to be able to say, this one is the new version, what Docker image hash it is, what's gone into that build, which code commits go into it. So there's like a long trace that you have to go back all the way to the commit line, where is that sleep 10? And it becomes much more difficult to find. And that's why something like this will help. So we call it build grid, and that's what the analysis does.
I had another observation.
Sure.
I ran the hello world.
Yeah.
And I noticed there's a couple other Docker containers.
Couple of other?
Collect D service and 3 or 4 other services running in the when I fired up the hello world.
Right. Yes. Okay. Very, very, very good observation. So.
A very nice job too. I learned a lot.
Right. So every server that you fire up with Cloud 66 to run your application has these things. Your application, obviously, but it also has collect-D, which is everybody's familiar with. It's an open source tool that collects metrics from your server, like how CPU is doing, how much memory do I have, how much disk do I have, and how much network backlog do I have. So that's we use to show you charts on Cloud 66 dashboard to see like everything, and you can put monitoring on it and all sorts of things, so I don't run out of disk space or things like that. There's also another thing that we run called Delphi, which is a product that we have, and that is a DNS server. It's a local DNS server. So every container that comes up, it actually points to that DNS server, which is a local one. And what it does is quite interesting, because you can say deploy, deploy, deploy 3 times in a row, because you had 3 commits that just gone in. And let's say you have a CI/CD that every commit, you have 20 developers, everyone commits, and at any time you have like 3 things going in. So you have 3 versions of your application in flight. You don't know what's now getting the traffic. The old ones are drained from traffic. You have a long file, large file being uploaded. You wait for that to finish to kill it before that, all sorts of things like that, right? However, let's say you have 2 services, web and API. If V1 of web, the old version of web, is asking for API, it needs to get the old version of API. If the new version is asking for API, it needs to get the new version of the API. Because you might have a contractual issue, like the API is not backward compatible or whatever that might be. And this DNS is aware of it because you deploy with Cloud 66. You know which version of which container has what version of your code. And just by the fact that it's asking that question from us that says api.cloud66.local, you know, your IP address is an old version. I'm going to give you an IP address of an old version of API, or the other way around. And that's how it's a version-aware DNS service and service discovery. So that's what you see as Delphi running on it. It's Weave, which is our network provider. So we use WeaveWork, which is a company that we use for the basic network provider. And we chose IP address of 25000 because we realized that no cloud provider is going to build a data center in Yorkshire in England. So if you have a cross data center network, the IP conflict is going to be minimal. So that basically provides a seamless network between all your containers and non-container components like databases and other things. Any other questions?
Sure. We use Cloud 66, and we've been looking into it at least.
Right.
We're not quite into production with it right now. But question for you, we're concerned about scaling.
Right.
So if a bunch of traffic comes in, we want to be able to scale up quickly.
Right.
And I guess that there's maybe 2 ways that we can do that. And I'm very bad with Docker, so maybe this is a stupid question. But so from what I've seen in the UI on Cloud 66, I can easily add servers, put a proxy in front of it, and get like round robin kind of thing going on there.
Sure.
But it also looks like I could put more than 1 container on a box.
Yes.
So what's the difference?
What's
How does
the
that work?
very good question?
Okay.
Yeah, that's a very good question. It's actually quite interesting. So here's an example of that. As you can see, we have 4 services. We have 4 services, so that was responsive. And this one's running 2 containers. Each one of them is running 1. It very much depends on the type of application that you're running. Now, an example of that would be Node.js. Node.js, everybody knows, is single-threaded one, so you might want to have multiple ones so you can leverage your multiple cores. Another example of having the benefit of running multiple is like if you have something that drains a queue to send emails, and you end up having a backlog because there's spike in traffic and emails that you have to send. But sometimes, some applications could be multi-threaded themselves, so you can actually get away by having one of them on the server.
I'm talking about WordPress in my specific.
Okay, in that specific example, I'm not a PHP expert, and I'm not a WordPress expert by any means, but I believe that you can actually get away with having one instance of that because it sits behind Nginx as an application server. So the whole HTTP, what Apache will do for WordPress will be done by Nginx. The application server side of it is something that I'm not really an expert on, but I believe you can actually have one instance of the whole thing. But might be wrong. Any other questions? Sweet. Thank you very much. Go on.
I've got one. It's not specific to Cloud 66
Right.
or even necessarily Docker in particular. Our current production app is running on Heroku, and we make heavy use of the proc file using non-web processes.
Yep.
We're moving to hosting on AWS with Docker images for a new project. If you're coming from a world where the number of instances for a given process are controlled via proc files,
Yep.
and scaling the number of those up and down, what are there any sort of best practices for how you would approach that in a non-Heroku based,
Right.
Either continuing to use proc files and Foreman or tools like that, or something that manages multiple sort of Docker images?
Right.
or
Yes.
containers running?
Okay. Great question. So the question is, using Heroku dynos and workers, you have a proc file. What is the best practice for people moving out of Heroku? And frankly, what we call ourselves, like we sit at the bottom of a PaaS cliff. People run on Heroku, everybody loves Heroku, and everybody starts with Heroku, nobody ends with Heroku. And people come to Cloud 66, a lot of them. I would love for you to come, and you should check out DigitalOcean. Better than Amazon. But no, in seriousness, what actually happens is we get this question quite a lot. Because Heroku obfuscates pretty much everything. There's a dyno and a magic and everything. There's no like a single unit of thing that you can take from one, say CPU cycle means CPU cycle, and a megabyte is a megabyte. No, there's like a dyno, and like they have to rest nowadays, and whatever that is. So there is a lot of magic involved, which means you cannot really translate that. And it's a very valid question. What my answer is, and this is something that I have to talk to my customers quite a lot, it very much depends, unfortunately. There is no magic bullet. It very much depends on what framework you use. Is it multi-threaded? Is it single-threaded? How much I/O bound is it? How much memory bound it is? So if you have a I/O bound process, means that you might have a single-threaded one, but that thread is going to get stuck because it's in a queue, or to write to the disk or whatever that might be. If it's not, it just goes and comes back and responds to something, puts something on a queue, whatever that might be, then you have a different scenario. And how many users do you have to serve for that? As in, it's non-web, I understand, but it could be how many emails you want to process, or how many calculations you want to make, how many matches you want to make in a dating site. We actually had that problem, which was quite an interesting one, because there was this dating site who's actually still our customer. They have like 1,000 men and 1,000 women who are heterosexual, kind of matching. It would be like 1 million combinations of different things, and as every single new member will add another 1,000 calculations to who's the best match. So there was a lot of kind of dynos, essentially, working on those things. And it was very much depends on how long it takes. In that case, it was very much a mathematical thing. It was very fast for every single calculation, so you could get away with having a very CPU-bound distribution, not much memory. But if you have a lot of like Redis, it's very much memory-bound. You have to think about that. I would be more than happy to help you on a specific case.
Sure.
Our team is, our support team is quite familiar with those things, especially coming from Heroku. But there's no magic bullet, I'm afraid. Sure.
I was curious if you were familiar with YesOg.
With?
YesOg is the
there's a moral equivalent of Rails and Haskell?
Oh, right. No, I'm afraid I'm not.
Have you guys deployed it or heard of anybody deploying it?
I'm sure if I look at, we have about probably 4,000 different stacks, unique stacks, and I'm taking out different environments of the same stack out. I'm sure there is that. I'm the least technical member of the team, so I'm afraid you're stuck with me. But I'm sure there is examples of that. I can dig it out. If you just send me an email, I'll put my email out at the end. If you send an email, I'll be more than happy to help you out with that. Well, my Twitter handle is there, but my email is khash@cloud66.com. Sure.
Couple of maybe two questions.
Sure.
One is I noticed that you offer like production, staging, development.
Yes.
Setups. Is there a difference between those?
In terms of performance, pricing.
Performance and pricing.
Right. So as far as performance is concerned, there's nothing that we do that degrades anything over another one. For us, the only thing that's different is a development environment. A development environment doesn't do backups and doesn't do load balancing, but it's free. So that's one side. As for anything else, you might say production, staging, QA, showcasing, whatever else, they are the same. What we find, however, is that many of our customers develop those things. You have their staging and QA on like DigitalOcean, and they have production on AWS or whatever that might be, and then they have a kind of a dehydrated version of the main thing on a couple of servers, one database, and everything else in another server. So it degrades the performance, obviously, but it's way cheaper, and it's much faster to spin up. And then production goes into a full-blown, 50 front-end servers, 3 databases, and whatever else that might be. And that usually works. We actually have a feature called failover groups, which allows you to clone a stack from one database, from one cloud provider to another, or one stack to another, switch the traffic over, do the database replication, cut it loose once it's up and running, and switch your traffic customers over.
And then the next question I have is, I think this is something that I've seen on like Google Cloud. They have so many different products, I don't know which one. But really, what I would like is to be able to git revert or git check out a previous version of my application, deploy.
Right.
What do you have like that? Like there's an easy way in the Google product where I can just generate a URL of a certain version of my application, send that to the client for them to review.
Yes.
Something like that in 566?
So you can use any git ref that you have, whether it's a hash or a tag or a branch, to deploy that however you want. And that can be built into an image. So you can say, I want that version to be into this Docker image, and then that be deployed. And you can go to this page that I showed you here. If you go to the build grid page, this page basically, you can have these are different versions that are built. Now this one was deployed, but this one wasn't. It was just to see if the build works. So you can have each one of them deployed, and you can go back and say, rebuild that, because there was an external dependency that wasn't in the version control that will change this build, which is not quite right. But we can say publish this. We can publish this. And that is just a built image, which will all it takes is for the old containers to go away and the new ones to come in. There's no build step or anything else. It's basically just a simple Docker pull, start them up, give them network, and all sorts of other things that happens, but it's fairly quick. So you don't need to go through the whole deployment cycle.
Okay.
And you can also do that by putting it into your Git commit hooks. So every developer will do that, and the whole thing starts and it goes to production or to staging. Sweet. Well, thank you, everyone. Thank you.